Hey, this is Kyle Munyon, teacher at Northside, here to help you guys with the area of regular polygon section. Hopefully you've gone through the warm-up, and these are the first slides that you would have to answer on the instruction section of area of regular polygons. So on slide 3, it has a few questions for you about this pentagon. The first one says the diagram shows a regular pentagon with side S already labeled for us. We can also see that we're going to explore some of the other properties as well. So press continue to partition. If you do that, you'll get the dotted lines on there. They're already drawn for you. If you press continue again, you do get the apothem, and you can see the apothem here is also already drawn. So we don't have to worry about drawing any of those things. They're already drawn if we just continue through them. On number 3, though, it says, based on the variables on the diagram, how can you find the area of the shaded region? Hopefully you can tell that the shaded region on your figure is this triangle right here. It's a little bit darker than the rest of the figure, and that's just a triangle. So we should be able to identify the area of a triangle equals 1/2 base of the triangle times height of the triangle. In this case, the base could be represented by S, and the height of the triangle that's perpendicular to the base can be represented by A. So the base is S and the height of the triangle is A. So we can represent the area of that shaded region as 1/2 the base times the height. So the base of the triangle is represented by S. We plug in an S. The height of the triangle is represented by A. We plug in an A. So we know that the area equals 1/2 side of the triangle times the apothem. All right, on the next question, we just answered this one right here. 1/2 SA should be one of your answer choices on there. On the next question, number 4, it says that, let me get rid of this stuff here. We can start on the next one. Because the triangles are congruent, what is the area of the entire pentagon equal to? So if we know the area of one triangle that we just identified, how many total triangles are there? There's 1, 2, 3, 4, 5. So it should be 5 times the area of one triangle. If we can find the area of this triangle, just multiply it by 5. So 5 times the area of the triangle, or 5 times 1/2 SA. Okay, so the should be 5 is what we plugged in on that one. For the next one, number 5, for the, sorry about that, for the next one, question number 5, how do I scroll up on here? Anyways, the area of the polygon is 5 times 1/2 SA. The blank of the pentagon is also equal to 5S. Well, if we take S and we multiply it by 5, then we should end up with the total length around the outside of the pentagon. So 1, 2, 3, 4, 5. We end up with equals the perimeter. So the perimeter, P, is what we get for this one, perimeter. All right. So if we take the formula for area, we know it's going to be 5 times the area of the triangle and we replace 5 times S with P, the area equals 1/2 P a perimeter times apothem. The P just replaced these two right here because 5 times the side is the perimeter. The A is still there for apothem, and obviously the 1/2 was there. So this is 5 times the area of a triangle. If we take the 5 and the S right here, that gives us perimeter, so we get 1/2 perimeter times apothem, or you could write it as area equals 1/2 apothem times perimeter of the regular polygon. On the next slide, number 5, it's asking us to find the area of this regular polygon. It gives us some dimensions for the apothem, 14.7 is already labeled, and the perimeter, 108, is already labeled in the question as well. So even though I don't have to draw anything on the picture, I will go ahead and put that the perimeter equals 101.8 inches to help make sure that we have that if we need to plug it in. So what is the area of this hexagon? We just need to plug in the pieces to the formula we just came up with on number 3. Area of a regular polygon equals 1/2 apothem times perimeter. And we can just plug in the pieces and plug it into our calculator. So area equals 1/2. The apothem is given, 14.7. The perimeter is also given, 101.8. And now we just need to type this into our calculator. If you don't have a calculator yet, you can use an easy one on your phone called Desmos Scientific Calculator or Desmos Graphing. That's an app or a website you can go to. Obviously, if you just type on your computer calculator, it'll pull up a calculator for simple arithmetic like this. In any case, on this one, we should end up getting 748.23 for the area. And because it is an area, we need to put the inches as square inches on there. Area is measured in square inches. So inches squared. Your answer already has that on there, though. I don't know if you select from this one or if you have to type it in, but 748.23 is what we get. All right, on slide number 7, very similar one in that it gives us enough information. We should be able to calculate the area of this octagon. It has 8 sides. So what is the area of the stop sign? The very first thing we should always start with is the formula of the area of whatever shape it is. So area of a polygon equals 1/2 apothem times perimeter. Start there. We do have 1/2 apothem times perimeter. So let's look at the problem and see what it gives us already. So each side measures 12.4 inches. That's not the apothem or the perimeter. And the apothem is 15 inches, so we can go ahead and plug that one in actually. So we don't know the perimeter yet, but we do know the apothem equals 15 inches. All right, so if I start plugging in, I realize pretty quickly that all I need is to figure out the perimeter. So 15 is the apothem, and perimeter is the whole length around the octagon. So because these are regular polygons, each one of these sides is 12.4. Oops, that's kind of ugly. In any case, there's 8 sides, so 12.4 times 8 will give us the perimeter on this one. So perimeter is 12.4 times 8. I actually don't even need to calculate what the perimeter is. I can just type it all in the calculator at this point. Let me make this a little bit nicer. 12.4 times 8. All right, so if you type all that in your calculator, 1/2 times 15 times 12.4 times 8, on this one we end up getting 744 square inches. And it's much easier if you type it in a scientific type of calculator where you can see everything that you type in before you press enter. That way you don't have to do it one step at a time. 1/2 times 15 times 12.4 times 8. It's just a little bit easier if you can type it all in at the same time to get your answer. So I would recommend that Desmos Scientific Calculator app or the website, Desmos Calculators. All right, number 10. For number 10, it looks like we need to find a few other pieces before we find the area of this one. It's first asking us to see if we can find the length of the apothem on this one. Then it's asking for the perimeter, because once we know those two pieces, we should be able to figure out the area, because area formula, once again, is 1/2 apothem times perimeter. And if I find the apothem and the perimeter, then I'll be able to plug those in and find the area. So first step is identify what the apothem of this 1, 2, 3, 4, 5, 6 of this hexagon is. So the apothem, remember, is from the center of the regular polygon to the perpendicular center of one of the sides. So the piece it gives us, 16 right here, is not actually the apothem, that's actually the radius of it. And that's not what we plug in here. We need to solve for this piece right here to be able to get the apothem of this hexagon. So the easiest way to do that is you'll notice we have a right triangle. Lots of different ways we could solve for these sides. You could use trigonometry, you could use right triangles. On the example before this one, they used right triangles, which means they knew this other side down here. I'll call it y for right now, but they use this other side right here to be able to solve for the unknown apothem that we're looking for. So let's see if we can't figure these pieces out. So if this is a regular polygon and this side is labeled as 16, that means that each of the sides is 16. So this whole distance right here is 16 inches. An apothem, conveniently, is a perpendicular bisector of the side, which means not only is it perpendicular, but it also cuts each of these exactly in half. So if the whole side is 16, that means half of it is going to be 8 inches. So 8 inches right there. So it looks like I do know exactly 2 of these sides. I should be able to figure out the third side, the apothem here, using a right triangle. So I'm going to draw another one over here real quick and just solve for this piece that is labeled A. So that will be the apothem. All right, I know that a squared plus b squared, we're using Pythagorean theorem, equals c squared. A is what I'm solving for, so a squared equals b is the other leg, 8 squared equals 16 squared. If I, should be a plus sign right there. If I start to solve for a, I can get rid of the 8 squared from both sides. Some of you guys may want to square these out. 8 squared is 64. 16 squared is 256. You don't necessarily need to do that because if you can do it in your next step in the calculator or leave it as a radical. So I'm going to subtract 8 squared from both sides. And I get a squared equals 16 squared minus 8 squared. Or if I do the last step, take the square root of both sides, I get a equals square root of 16 squared minus 8 squared. Now you could type this in your calculator. You don't need to though. You can leave it like this because we can actually plug that whole thing in right now like that if you wanted to before you even type it into your calculator. So if you wanted to, you could type in your calculator. I don't know what you get.